All right, so picture this. You're putting together this massive music festival, hundreds of miles inland, everything's booked, tickets are gone, and then you see it forecast a potential hurricane.
Yeah.
Right, where you've got the main stage set up. Talk about a nightmare.
Oh, yeah.
But now imagine having like 3 extra days to react, to maybe relocate, secure equipment, who knows, maybe even postpone. That's the kind of power we're talking about today. This deep dive is taking us into AI weather forecasting. We're going to explore Google DeepMind's GraphCast and why this is way bigger than just some tech upgrade. This could actually change how we deal with the weather entirely. And lucky for us, we've got our expert here to break it all down.
Absolutely. I'm ready to dive in. This is exciting stuff.
Okay, so before we get into how GraphCast does its magic, let's talk about the problem it's trying to solve. Traditional weather forecasting, it's a bit like trying to solve a giant jigsaw puzzle, but with half the pieces missing and you're riding a roller coaster at the same time.
That's a pretty good analogy, actually. It's incredibly complex. Imagine giant supercomputers, the kind that take up entire rooms, spending hours and hours just crunching through physics equations, and all that just to give us a glimpse of what the weather might do tomorrow.
Exactly. And even then, it's not always reliable, especially when we're talking about those really big, scary weather events, the ones we really need to be prepared for. But then GraphCast enters the scene and kind of flips the script. Instead of equations, it's all about data. And not just a little bit of data. We're talking a whopping 40 years of historical weather information.
Yeah, it's like we're feeding a supercomputer the entire history of weather patterns, instead of just handing it a textbook definition of how weather works. And honestly, that's where the real power lies.
Okay, so we're feeding it decades of data. But what's the recipe? This is where things get really cool. GraphCast uses something called graph neural networks, or GNNs for short. You ever notice how Facebook can somehow tag your friend in a photo, even if their face is half hidden?
Yeah, it's crazy.
It really is. Well, GNNs are kind of like that. But for weather, they can see those patterns and connections in the data, connections that traditional models might completely miss, which makes them really, really good at predicting how weather systems evolve.
And it's not just any data we're talking about here. This is like the creme de la creme of weather data, ERA5. From the European Center for Medium-Range Weather Forecasts. I mean, think of it as like the gold standard, the most comprehensive, high-quality global weather data set out there. It combines actual observations from satellites, weather balloons, those weather stations, you name it.
Wow.
ERA5 is seriously impressive stuff, and that attention to detail, that's what makes it so valuable. And that's why GraphCast is built on such a strong foundation.
So it's like, instead of trying to learn to bake from a recipe you found scribbled on a napkin, you've got this seasoned chef who's been perfecting their craft for years.
Exactly. And you can see it in the results.
Yeah.
GraphCast can make a 10-day forecast in under a minute, and all of that on a single Google TPU v4. Those are those specialized processors they designed specifically for machine learning.
So, okay, it's fast. But is it any good?
Oh, it's good. Fast A&D, good. I mean, traditional models often need hours, even days. On those massive supercomputers we were talking about, GraphCast doesn't just speed things up, it's also more accurate. We're talking outperforming the traditional methods on over 90% of the weather variables they tested it on, especially in the troposphere.
Okay, so now you might be thinking, what's the troposphere and why should I care? Well, it's that layer of the atmosphere closest to Earth, where we live and breathe, where pretty much all the weather we experience happens. So getting those predictions right, super important, especially when it comes to those extreme weather events. Which brings us to why all of this really matters. Remember that music festival we were talking about? That wasn't just a hypothetical. We've seen how traditional forecasting can go wrong, like with the recent hurricanes.
Totally. Hurricane Lee last month, perfect example. GraphCast nailed its landfall in Nova Scotia 9 days out.
9 days.
9. Traditional models were still struggling to figure it out at 6 days.
See, that's what I'm talking about. 3 days might not sound like a lot, but when it's a hurricane we're talking about, those extra 72 hours, that could be everything.
Absolutely. That's so much more time to evacuate people on the coast, get emergency teams in place, secure infrastructure. It could mean a city goes from bracing for a disaster to actually being ready.
Right, and it's not just hurricanes either. GraphCast has been crazy accurate predicting atmospheric rivers too, which, have been all over the news lately. These things are like huge rivers of moisture just flowing through the sky. And when they hit land,
Oh, man.
Look-
The flooding is unbelievable.
Exactly.
I mean, we're talking rainfall that can overwhelm any drainage system, causes so much damage, and just displaces entire communities.
So knowing where and when these atmospheric rivers are going to hit, that's key for any kind of early warning system.
It really is.
So it's like if someone told you they were going to point a fire hose at your town in a week, you'd want as much time as possible to prepare, right?
Right.
And get this, GraphCast isn't just some research project. This is happening. The ECNWF, one of the top dogs in weather forecasting, they've got a live experiment of GraphCast running on their site right now.
I love that. And they're not keeping it to themselves either. Google DeepMind open sourced the code,
Whoa.
which means anyone can basically use it, play with it, build on it.
Okay, so for our listeners who aren't programmers, what does open sourcing actually mean? Like, what's the big deal?
It basically means they made the recipe public, like they shared their secret sauce with the whole world.
Wow.
So now we could see a future with totally customized weather models, tailored for specific regions or even industries.
So you're saying, like,
Exactly.
Oh.
Imagine farmers knowing exactly when to plant to get the best harvest. Or energy companies knowing exactly when to optimize for renewable energy based on super accurate wind and solar forecasts.
okay, so now that's what I call a sunny outlook. But beyond all the practical stuff,
Yeah.
what blows me away is how this tech could help us deal with climate change.
Right.
Because as climate change makes all these extreme weather events more frequent, more intense, having these really accurate long-range forecasts is going to be crucial.
Absolutely.
Imagine knowing weeks in advance that a heat wave was going to hit a certain
So
area.
you could get resources in place.
We could help the most vulnerable people.
Exactly, potentially save lives.
It's like having a crystal ball.
Yeah.
But instead of vague predictions, we get real insights backed by data.
Exactly.
It's not just about reacting to the weather anymore, it's about getting ahead of it.
100%.
And this is just the beginning, right?
Right, yeah.
As our data gets better and our AI gets smarter, who knows what we'll be able to predict.
Exactly.
That's both exciting and a little bit scary, don't you think?
Yeah, it is.
So as we wrap up our deep dive into the world of AI weather forecasting, here's something for you to think about. If we can teach a computer to predict something as complex and chaotic as the weather, what other mysteries could we unlock? With that kind of power, that's a question worth pondering. And for our listeners who, like me, can't get enough of this stuff, we'll link to the GraphCast live experiment in the show notes so you can check it out for yourself. Until next time, stay curious, my friends.